So today I want to tell you about optimization. So this is going to be this is going to be the first lesson that I'm going to give you guys on optimization, and then there will be another one later on. So it's called Optimization 1. And so first of all, I need to introduce a little bit of terminology here. So in optimization problems, we're usually optimizing a specific function, meaning we're trying to find the maximum of a specific function or the minimum of a specific function. So that type of function is called an objective function. So an objective function is the function that we want to find the maximum of or minimum of. All right, next, a constraint is basically any other formula that applies to the problem. So commonly you'll have constraints like x between minus pi and pi, or subject to some other condition on the function, like or some other condition on x, or whatever your dependent or independent variable is. So like x squared equals t squared could be a constraint. And a function would often appear to be something like f of x equals 4x squared minus 5x. That would be an interesting function to optimize. For example, that's a very simple example. If we wanted to find the maximum value of f of x equals 2 sine x on the interval from 0 to pi, and we wanted to also find where that value occurs, I would start by graphing the function. So this function looks like the following thing. It starts at 0 and it goes up and then it goes down. Basically, it looks like a sine function, but the difference is that the amplitude of this guy is going to be 2. So this is our f of x. And down and up and down and up. Okay, so this is going to have amplitude 2. And we're interested in finding the maximum value of this function on the interval from 0 to pi. So 0 is right here. This is the x-axis. And this is pi right here, because this is 2 pi. So pretty clearly, just by looking at the graph of this thing, you can see that this part of the function over here is not relevant to the problem at all. And really, we're just looking at this other function there, right? Oops. Really, we're just looking at this one hump of the function, which is near the origin. And so just from looking at that, I think it shouldn't be too hard to convince you that the maximum is happening right at the top here, right? At the top of this hump. And okay, where's that going to happen? Just by standard facts about the sine function, I know that that's happening at x equals pi over 2. So the value where that maximum happens is x equals pi over 2, and the maximum value is f of pi over 2 equals 2. So the maximum value is 2. Okay, so that's a very simple example. We're going to be dealing with some more complicated or more non-intuitive examples in the future. So let's look at one of those soon. First, I need to tell you about the general technique. Okay, right. So general technique for optimizing functions is first you find the critical points of your objective function. So it's always the objective function that you're trying to optimize. So you're going to look at the critical points of it. And then you want to find the endpoints of the objective function also. And then you just want to check then you want to check all of the critical points and all of the endpoints to find the best solution to the problem. And of all of the possible solutions to the problem, the best and worst values are guaranteed to happen at critical points and endpoints. So your function is going to be optimized at one of these values that you found in parts 1 and 2. Right, and the reason why that is because the function can't have a local maximum or a local minimum unless it's at a critical point. And the only other way that it could exceed the local maximum or local minimum would be if it's at the endpoints. So here's an example. I want to find the maximum value of f of x equals 3x squared on the interval from minus 2 to 1, and I want to find where that maximum value occurs. So first I need to find the critical points of my function. So my function, my objective function is f of x equals 3x squared. So this is my objective function. And my only constraint on this problem is this. And apart from that, the problem just tells me to find the maximum value and find where it happens. Okay, so I'm just going to sketch this out for you and show you that we already pretty much know what this looks like, right? So f of x is 3x squared, so it looks like f of x equals x squared, but it's a little bit steeper. And so it's pretty clear that, okay, so, and then we've got the interval from -2 to 1. Sorry, I shouldn't draw that as a bracket if I'm on the line. So -2 is going to be up here somewhere on the function, and I'm not really quite sure what that value is yet, although it's not too hard to find out. And then 1 would give me some value over here on the function, and that's going to give me a different point on the axis. So it's pretty clear that the maximum value is going to happen here, and that maximum value is going to be f of -2, which is just a number, and in this case, f of -2 is equal to 3 times -2 squared, which is 12. Okay, so so the maximum value is going to be 12, and the maximum value is going to occur at x equals -2. So why give the so let's see how we can apply this technique to solving this problem. So first of all, we want to find the critical points of our objective function. So the critical points are the points where f prime of x equals 0. So what is f prime of x? Well, f prime of x is 6x. So I want to solve the equation. Whoops, 6x equals 0. So that's pretty easy, right? The only solution is x equals 0, and that is our only critical point. And then next we want to find the endpoints. So the problem gives us these. So the endpoints are x equals -2 and x equals 1, right? And then the third step of the problem is we want to check all the critical points and endpoints to find the best solution. So fine, so I'll check f of -2, and then I will check f of 0, and then I will check f of 1. So endpoint, endpoint, critical point. From left to right, f of -2 is 3x squared, so that's going to be 12. F of 0 is going to be 0, and f of 1 is going to be 3. So this is going to be the minimum, and this is going to be the maximum. And since the problem asked us to find the maximum, this is what we want. But if we had been asked to find the minimum, sometimes the problem will ask us to find both the minimum and the maximum, then we would have gone with this answer, right? And then this one doesn't really apply in either case because it's in between those two values. Right, and that maximum value occurs at x equals -2. So that's where the max value happens. So moving on then. Here we've got a kind of a non-intuitive problem. So in this problem, we're given a function by its graph. So we're given the graph of a function, and we're asked to find all this optimization stuff. So the problem tells us that the function f of x has the following graph, and it wants us to find the following information. First, we want to find the domain. Second, we want to find the critical points. Third, we want to find all the local maxes and mins. And fourth, we want to find the value of x where f reaches its minimum height. The minimum, or sorry, the value of x where it reaches its minimum, sorry. And then we've got to find the actual minimum. So I'll give you a few seconds to think about this problem. It would be a good use of your time to pause the video and try to work it out yourself. All right, welcome back. Hopefully you thought about it. We want to find the domain of f. That's actually not too bad in this problem. So our graph is defined all the way out to -infinity, it looks like, and but it stops here at 3, right? So the domain of f is from -infinity to 3. Okay, so there's no end point at this end of the domain. It just kind of keeps going forever. So the only end point is x equals 3. So next we want to find critical points of this function. So remember that a critical point is when f prime is equal to 0, right? That is equivalent to saying that f has slope 0. In other words, it's got a flat slope. So where does that happen in this graph? It happens once right here, and it happens again here, and it happens again here, and it doesn't happen any other points, right? So conveniently for us, all of those points are labeled on the graph. So one of them is happening at x equals minus 1. Another one is happening at x equals 1 over 4. And a third critical point is happening at x equals 3/2. Okay, so these are our critical points. Okay, and from there we want to find all of our local maxes and mins. So remember, a local max and min by definition can only occur at a critical point. And in this case, we've got two different things to consider. We've got local maxes and local mins. So we've got a local max right here. So the function keeps going up forever. So there's no local max in that direction. But here it reaches a max and then it goes back down. So this point here is a local max. So there's a local max at x equals 1 over 4. And there are local mins at 2 points, right? One is here and another one is here. So x equals minus 1 and x equals 3/2. Okay, so those are our local maxes and local mins. All right, so next we want to find the value of x where f reaches its minimum height. And it's pretty easy to see from the graph that that's going to happen right here, right? So x equals minus 3 over 2 is the only place where that could happen. And then we want to find the minimum height of the function. So that would be minus 10 on the x-axis. And I will give you a little bonus here, which is what if the problem asked us to find the maximum height? There would be no maximum. Why is there no maximum? Because as x grows more and more negative and goes out to minus infinity, my function just grows uncontrollably. It keeps going up. Okay, so now I've got another example for you guys. In this example, we've got the trajectory of a projectile. It is being given by some function, so 10 plus 9t minus t squared is our function. And the problem tells us that the projectile is launched at the time t equals 0, and it stops at the time t equals 10, probably because it hits the ground. And we want to find the maximum height attained by the projectile, and we also want to find the time when that height is reached, right? Just in terms of the terminology that we introduced at the beginning, this is our objective function. And we have some constraints here. It's launched at the time t equals 0, so t is greater than or equal to 0, and it stops at the time t equals 10. So t is going to be between 0 and 10, so that is our constraint. Okay, from there, I'm going to go ahead and do my three-step process. So let me go ahead and find where that was. So the first step is to find the critical points. The second step is to find the endpoints. And the third point is to check all of those critical points and endpoints, right? Okay, so the first step is to find the critical points of our objective function. Our objective function is f of t equals 10 plus 9t minus t squared. So our objective function is always defined. To find the critical points, we just have to find when f prime of t is equal to 0. So to do that, of course, we first need to compute f prime of t. F prime of t is 0 plus 9 minus 2t, so it's 9 minus 2t. Okay, so solving the equation f prime of t equals 0 is equivalent to solving 9 minus 2t equals 0. So that would tell me that t is equal to 9 over 2. So that's our only critical point. The next step of the problem would be to find the endpoints. And in this case, the endpoints are given directly by the problem. Time is going between 0 and 10. T equals 0 and t equals 10. Okay, and then I just need to check my objective function at all of the critical points that I found and at all of the endpoints in order to find the best solution. So once again, my objective function was f of t is 10 plus 9t minus t squared. That means that f of 0 is 10 plus 0 minus 0, so it's 10. And that tells me that f of 9 over 2 is, well, it's 10 plus 81 over 2 minus 81 over 4, which is 10 plus 81 over 4, which would be 40 over 4 plus 81 over 4, so that would be 121 over 4, which is exactly 30.25. Okay, and the last point we need to check is f of 10. F of 10 is 10 plus 90 minus 100, so that is going to be 0. So the three values we found were 10, 0, and 30.25. Clearly, this is the maximum, and this is the minimum, and this one is neither. And we were asked to find the maximum, so we don't actually care too much about this one. So we've pretty much solved the problem now. Okay, so the way I would write this in plain English would be that the projectile attains its maximum height of 30.25 at the time t equals 9 over 2, or 4.5. All right, I think that's about it. See you in class.